A very good morning to everyone present over here. Today, let us discuss about the subject IoT processors, and in this we can look forward into the unit 1, which is nothing but the overview of ARM and also Cortex M3. And here in this we look forward into the first topic, which is nothing but the ARM architecture. So, in the embedded systems itself, you would have studied about the ARM architecture. First of all, we could see what is meant by the ARM. It is nothing but the advanced RISC machine architecture. And here we have 4 areas, which is nothing but the programmer's model, instruction set, memory model, and also the debug architecture. So before going into that, we first see about the evolution of the ARM. ARM, as I told you, it is nothing but the advanced RISC machine, where it has been started or invented in the year 1990 with a joint venture with the Apple computers and Account computers, whereas with the VLSI technology. And also here it has been extending the application of the ARM processors into the mobile phones, computer hard disk, and personal digital assistant, because everywhere we are using our PDAs, various devices we are using even at homes also, and also for the entertainment systems and also for the consumer products. So here ARM processor we have been using into the large number and into the high performance microcontrollers. We know ARM, it is the advancements of the microcontrollers, and also nowadays in the mobile phones, in which we are using in our everyday life. Without that it could not be exist like that. So here this ARM architecture have been classified into 3 categories, whereas and this ARM architecture we are seeing about the version 7. So because once it has been introduced or invented, it has been gone through the advancements or the enhancements throughout the years. So like that, here it has been divided into 3 categories. The first one, it is called as the Cortex A, and the second one is called as the Cortex R, and finally we have Cortex M. Cortex A is nothing but it is the application oriented processor, and also we have Cortex R, that is nothing but we are using it for the real-time processor, and finally we have the Cortex M, which is nothing but the microcontroller cores. It is also used for one of the application. And Cortex A we have, it is the high-end support, that is the high-end support system, or we can say as a high performance system, such as our smartphones and televisions and our tablets and also our computing servers also. And we have the next one, that is the Cortex R. Cortex R is nothing but it has been specifically used for real-time high-performance processors and also for the automotive systems, and it is used for the high reliability, because every system we introduce, we have to use it at the best with high reliability, that is the efficiency at the best. And finally we have the Cortex M. As I told you earlier, it is for the microcontroller cores, and also it is used for the real-time control systems. So these are about the 3 categories, and now we look forward into the first one, that is nothing but the programmer's model. So in this we have the first step, it allows the ARM processor into the FPGA. FPGA is nothing but the field programmable gate array. It is used for the programming. And the second step we have, it is to address the ultra low power embedded processor, and the result of this ARM architecture, that is it enables the development of every small and also the energy efficient processors also. And the second one, we have the instruction set. So already we have studied about the instruction set of 8085, 8086, or why not the controllers, and so many. But we have here instruction set, it supports the 16-bit instruction set. And here the thumb 2 instruction set it supports both the 16-bit and also the 32-bit instruction set. The very important factor, without the switching mode, we can just mix it and getting the high code density and also the high performance with no extra complexity, because when we combine both, definitely as usual or in a usual manner we used to get some of the complexities, whereas in this we don't have any kind of the complexities. So here we have the Cortex M3 and also the M4 processors. It also supports the unaligned data accesses. It also available only in the high-end processors. As I told you earlier, it all supports only for the high-end processors or for the high performance systems such as our smartphones and televisions and so on. Nowadays we have OLED and so on. And the third one, we have the memory model. So the memory model, we have the load store architecture. This we could have already studied. So in this access of the memory data via, that is through the instruction load instruction, that is through the instruction it passes, and the load instruction copies data from the memory to the register file, whereas the store instruction writes the data from the register to the memory. And we have for high language programming or high language processors, we have the memory model. It describes the behavior to access the shared variables from machine code or memory model. It describes the behavior of the hardware infrastructure or the hardware instruction that accesses the shared memory. This is about the memory model. And finally, we have the debug architecture. So it has been designed exclusively for the complex SOC. So SOC, we know that is the system on a chip. So it will be having the that is the debugging multi-language or the multi-modeling system. It works with the single that is the processor. So the multi-processor we have system, it is working with a single processor. So this all about the ARM architecture, where we have discussed about programmer's model, instruction set, memory model, and finally with the debug architecture. And we have earlier discussed about the version of this one, that is the version 7 ARM, that is the V7 architecture. And also we have the 3 categories: Cortex A, Cortex R, and also Cortex M. Hope you all understood. Thank you very much.